How is it possible that I can communicate with my smartphone practically everywhere? That is the question we will answer in this video. The transmission power of a terminal or a UE in the 4G vocabulary is typically 0.2 watts or 200 milliwatts. The range with such power obviously depends on the situation. In other words, if I'm in the city, it's not the same range as if I'm in the country. But we can give, as an order of magnitude, a maximum range of several kilometers for a strength of 0.2 watts. That means if I'm very far from the base station antenna, I'm not going to be able to have my communication, my access to mobile internet. What the operator will do is deploy base stations as regularly as possible in order to cover the territory in a way that wherever I am less than a few kilometers from a base station. Of course, in practice, this is not true. There are white areas where there is no coverage. But having base stations everywhere is the ultimate objective. Now, the question is how to know if I have access to the network, whether I actually am close enough to a base station to have access to mobile internet. For that, each base station periodically broadcasts a signal called the beacon channel. This beacon channel first enables indication of the presence of the network, and it gives the characteristics of the network, among which the identity of the operator. This way, my terminal will try to listen for my operator's base station and not that of the competitor. All terminals measure the strength with which they receive this beacon channel. We've made a simple example on the drawing. The transmission of the beacon channel is symbolized by these concentric arcs. When the person is close to the base station, the received signal is very strong. This corresponds to having a lot of bars on the terminal display. The further you are from the base station, the fewer bars you have. When the terminal does not detect any signal, well, then it displays the message "no network," and logically there aren't any bars. Let's get back to the grid of base stations over the territory. Here we have an example around Rennes, where I live and work in France. The scale is 5 kilometers. When there is a 1, that means that there is one base station. And we can see that the base stations are relatively regularly placed to provide coverage. If we look at an area around Rennes, Rennes is about here. We see that in the area surrounding Rennes, the base stations are a little more densely arranged than in the previous case. And if we look at the downtown, it's the following slide. We have Rennes. The scale is 2 kilometers. Base stations are densely arranged. And when we have the number 2, it means that there are 2 base stations not too far away. What does that mean? That means that the operator, when it has a lot of customers to serve, will deploy a large number of base stations. And the area covered by a base station, called a cell, is smaller. In the suburban zone, it will be a little larger. And in the rural zone, it will be much larger, from several kilometers up to a radius of 10 kilometers. The concept of cells consists of dividing the territory into cells, each one served by one base station. For people who access the network, their terminal transmits to the base station, and that signal is then sent into the network. Ideally, the division into cells is imperceptible to the user. That's the objective. Passing from one cell to another when the user moves should be completely invisible. What we could show with a small mathematical model is that the capacity of a cell, that is the number of megabits per second that one can transmit by cell, does not depend on the size of the cell. In the urban area, there is a high density of users. In this case, the base stations are deployed much more densely because there's a problem of capacity. The operator should deploy enough base stations so that the capacity in megabits per second per square kilometer is superior to the traffic created by the customers. In rural areas, there is a low density of users. So the operator will try to just ensure coverage. The operator should deploy enough base stations so that at every point of the territory, a terminal is under the range of a base station and can connect.